I think if you flip it, you get it wrong. I've already put it in the right notation, the right way for you.
Multiply 8 by...
I don't know. This has nothing to do with matrix, what I'm asking you. This is normal, and you solve a normal problem. It has nothing to do with matrix. I just asked you to put it in a matrix form. Yes, anyone ready? Okay, let's see, what do you have? Again, who has not done it? Or who is not sure? You're not sure what you have done, raise your hand. Okay. Who is very sure? Oh, I'm sure what I did. Raise your hand. Nobody? Okay, we don't have to be sure. I'm trying to make sure that.
You have to also do this once in a while. Okay.
So in and out, like that. Because that makes it better when you guys want to review it later. So you zoom in and out. Okay. Let me have your results. Let's have your results.
600.
600.
1,500.
What?
1,000.
This one?
Yes. 1,500.
1,500.
1,000.
1,000. Yes.
1,800.
1,800. 0.
0.
0.
200.
200.
2,400.
2,400.
2,000.
2,000.
2,000.
400.
400.
Who got this? Okay, then you're right. I don't know why you're not sure. What I ask you to do has nothing to do with matrices. The given problem was, this is the inventory of a store. I would expect everybody to be attentive now. This is the inventory of a store. You sell these sizes, you sell shoe types like Nike, Adidas, what other one is very popular?
Puma.
What?
Puma.
Puma, yes. I remember that Puma. That Puma is actually very popular when I was growing up. We use, no, it doesn't mean shoe. When somebody says you're like Puma, trust me, they mean you're being too forward. Yeah, because look at the shape of that logo. It looks like someone jumping up, right? So it's like, oh, why are you being too forward? Anyway, that's some kind of slang I grew up with. So let's say we have Adidas, Nike, and Puma here. Now, you sell these sizes of those shoes. And when you check the inventory of your store, this is what you have. You have Adidas size 11.2. Adidas size 12.6, Adidas size 13.8, like that. This is the meaning of this. This is how much you sell these shoes. Adidas shoe type, you sell them for 300, which means you don't care about the type. Something like that, yeah? For this, you sell for that amount, and for Puma, you sell for that amount. So I believe you must have done Adidas this times 300, right? Is that what you have done to get this 600?
Yeah.
Okay, then what again?
6 times 300.
Then you do 6 times,
300.
okay, then what again?
And 8 times 300.
There's something you have not done. What is the question I ask you? Give a revenue matrix showing how much you made for each size of shoe. So for size 11, for size 12, for size 13. What is the revenue for size 11? How much did you make as from the sales?
3,000.
3,000? Is that what you got?
Yeah.
Yeah, that's the right answer. This is just halfway. So what are you supposed to do next to this? Talk to me, everybody.
Minus 3.
Minus 300. Class, please. You're making the class more boring for me. Seriously. Yeah, I'm asking you a basic question. You don't have to be right or wrong. Just speak out. Again, this is correct so far, but this is not the last thing I ask you. Look at what I ask you. Give a revenue matrix showing how much we made, not the profit. That's why I told you what revenue means at first. when you sell something, every penny that comes into Samuel, that's the revenue. But that's not the profit made by Samuel. Does that make sense? So what is the revenue we made on each size? Nobody's talking about type here. On each size, we don't care if it is Adidas or Nike or Puma. We are talking about the size of shoe. So how much did we make on size 11 shoes? Talk to me, everybody, please. What about size 12?
2,000.
What about size 13? 4,800. So this is not the last result. The last result means you have to do what to this? Combine them. Now, can you walk me through the process that led to this? So I write this out. Instead of Adidas, Nike, blah, 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 okay? All these numbers, I'm going to write them as this. A, B, C, D, E, F, G, H. Instead of I, maybe I say K. I don't want I to look like 1. Okay? Then for the other one, I use X, Y, Z. Eventually, you got something that looks like P, Q, R, right? Because this is just one number.
Yes.
And say you need to stop that, or I ask you to leave the class. Does it make sense? So walk me through what you did to this that led to this one. Yes? AX.
BY.
I don't know why you're saying this. Walk me through what you did to this to lead to this. So which of this is exactly the P?
Multiply the first followed by the...
You are not, you are still saying the right thing, but you are not just, after the correction, I can't believe you are still going back to this.
Plus BY.
Plus BY. Walk me through what you did to this to give this. Why are you still telling me in bits after we agreed this is not the case? Yes. What is the next thing?
CC plus
Plus.
CZ. X plus Y.
Please, who doesn't understand what I'm saying here? Anyone who does not understand, please. Okay, so for the Q part, what did you do?
DX plus
Plus X.
Yes?
GX plus HY
Plus KZ.
Plus,
KC.
what you have done is to multiply these two matrices together. This is how we do matrix multiplication. That's why I gave you that problem. If you are able to go through this using just common sense, you don't need to know what a matrix is. You get this out. What you have done indirectly is multiplying matrices. Now let's go through it again. Basically what you did is to bring the elements in each row and bring them to the column one by one. So A, B, C. A is at the end of the arrow, C is at the top of the arrow. Can you see that? So your A is here, your C is here, your B is here. So what you did was to do this times this times this times that, and add the result together. We call this type of multiplication row by column multiplication. Row by column in the sense that you always bring the row of each matrix and multiply it column-wise, one by one. Now, what is the order of this result? Remember what order means from yesterday?
Oh.
What is the order of this matrix?
3 by 1.
3 by 1. Thank you. What is the order of this one?
3 by 3.
What is the order of this one?
3 by 1.
So let's see from what I told you yesterday. 3 by 3 multiplies 3 by 1. What is the result? 3 by 1. The last thing I wrote yesterday, was it the last thing? Is something like this. If a matrix is of order m by n, right? And the other is of n by r, then the result must be of order m by r. Do you remember this from yesterday?
Yeah.
You see why this must be the same now. If you bring this row and this does not have 3 columns, you get what I'm trying to say now? Sorry. If you bring this first row to this column, now how many elements are in this row? 3, because there are 3 columns. Remember, each element belongs to each column, right?
Yeah.
So that's why there's a reason. What was that principle you said before we started? For multiplication to be possible, yes,
The columns of
the number of columns, not the column. The
number of columns in the first matrix
Mhm.
equals the number of rows in the second.
do you understand that?
Yes.
The number of columns in the first one must be the same as the number of rows in the second one. That's the key. Why is that possible? Well, we can see here. The number of columns in this is 3. That's why there are 3 elements when you bring this down here. And each must be able to multiply to something. That something is the number of rows in the second one. So the column here, the number, must match with the row here. Otherwise, this multiplication will not be possible. Does it make sense? So that's the first thing. So my question is, can you multiply 2 matrices, each of order 2 by 2?
Yeah.
You can't.
Are you sure? Please, you guys need to be checking if otherwise you can zoom out, so you don't need to move around too much. You need to capture everything because of those that are not here. Okay, can you multiply 2 matrices of order 2 by 2 each?
Yes. Yes.
Are you sure?
Yes.
Kinlon, what do you think? The first matrix is 2 by 2, second is 2 by 2. Can you multiply them?
Yes.
Yes. Just put it down. Right? It's possible. We don't care what this is. Can you multiply 2 matrices of order 3 by 3?
Yes.
Yes?
Yes.
Are you sure?
Yes.
Think very well. Are you sure?
Yes.
Because I don't think so.
Yes.
Denise, what do you think?
Yes.
Sure? You don't have to go with them.
No, but
Go with me. I don't think it's possible.
no, but I think
You should trust your teacher more, remember?
no, but I think
She's like, wait, what is this dude talking about? Okay, it's possible. Okay? So, what can you say? Square matrices. We can multiply 2 square matrices of the same order. Right?
Yeah.
So, if a matrix is n by n, you can find n by n, another n by n to multiply it. Is that alright?
yes.
Okay. My question is, if a matrix is of any order, can you multiply it by the matrix of the same order?
No.
Give me a reason why you cannot.
Because you
Oh,
could,
it
because
doesn't-
they're rows
it
and
doesn't
columns.
have to be the same.
It may not be the same.
It may not be the
So if the order is m by n, and you multiply by another m by n, then that's not possible.
The rows and columns.
Do you understand that?
Yeah.
Unless you have what? n by
times
n. What do we call this matrix and this matrix? There is something I mentioned yesterday. If you have a matrix and you want to change it to the one of n by m,
Inverse.
no. Start with a T.
Transpose.
Transpose.
Oh.
So, can we multiply a matrix and the transpose of the same matrix
Yes,
together?
yes.
Yes. So, if this matrix is m by n, the transpose will be of n by m, right? Then we can have, what kind of matrix is that?
Square matrix.
A square matrix.
Wow.
Always a square matrix. Okay? Of order m by m here. If you start with the transpose, look at it. And the matrix itself, what do we have? Is it still a square matrix?
No.
Yes. Does it make sense?
Yeah.
So this is called row by column multiplication. The condition is simple. The column in the first, the number must be equal to the number of rows in the second. You don't need to memorize that statement. Just write this multiplication, whatever, and see if this cancellation holds. Okay? All right. Now, let's go to some real examples. Let me show you one or two examples. After that, I just maybe do one or two, then I write questions on the board. You try it one after the other, compare it with somebody beside you, and that's it. Let's start with, maybe I just take some from mine. I think I still have some of them in mind. Well, they're staying there for how many years now? They're not paying rent, I don't know. So let's bring them out. Isaac, everything all right? Okay, so let's see. This matrix is 1, 2, 3, 4. I want to find the square. What does square mean in this case now? Again? Multiply by the same matrix. And same thing before you say something. Try to say, I said what does square mean in this case?
I couldn't see when you were.
But you heard what I said.
Yeah, I think you mean that's way.
Ah. Okay, so 1, 2, 3, 4. Multiplying by 1, 2, 3, 4. That's the meaning of that, right?
Yeah.
So, what I encourage students to do is take pencil and do this arrow thing. That is what I will learn as beginners. And bring the arrow down here. Okay? So you take the first row. Please pay attention. You take the first row, 1 and 2. Can you see that? Then you do the multiplication. So I wouldn't write the bracket first until I'm done. So 1 times 1, we had 2 plus 2 times 3. So 1 times 1 will be added to 2 plus 3. Can you see that? So I multiply this with this. So I go like this. This times this and this and this. Okay? That's exactly what we did there. Unlike this, we have another maybe selling price. And another maybe selling price. Can you see that? So I'm just making it more. Okay, so this goes for this. Then this same number, we have to multiply the second one. Then that would be 1 times what? 2 added to 2 times 4. Please talk to me. You have to say something, otherwise you won't really get it faster. So now, 1 and 2 has completed all the possible columns to multiply. Then the next we take 3 and 4. So the same arrow now takes 3 and 4. Can you see that?
Yes.
So when 3 and 4 multiplies this, what do we have?
3 times 1.
3 times 1, plus
Plus 4 times 3.
4 times 3. Anika, please confirm that we can see this. And this one also?
3 times 2.
3 times 2 plus
4 times
4 times 4. Then I put the brackets. Remember yesterday we can use the normal bracket or the square bracket. Okay? So now, the rest is just to add. What is this? 7. The next one?
10.
10. Are you sure?
Yes.
Okay? Let's trust him. Next?
15. 15.
15. Next? 20.
22. Yeah.
Can you see that it's not the square of each element in the matrix now?
Yes.
Let me give you a clue. There are 4 positions in the matrix, right? This is top left. This is top right. Right? This is bottom left. And this is bottom right. Oh, right. Okay. Sometimes the brain is like that. You're saying something, the brain is writing something. Okay. Now, why do I take note of this? Why am I saying this? You pick this element from the first matrix, you pick from either the top or the bottom. Okay? From second matrix, you multiply by either what?
Left or right.
The left or right. So when you pick from the top and you multiply the left, the answer is on the top left. Did you notice that? Okay? The same numbers from the top, multiplying the right, the answer is where? On the top right. Tell me if you understand or not.
Yes.
Okay? Then, after you are done with the top, because there are no left, right, or center anywhere anymore, you start from the bottom, then you have bottom and left, you have it here, the bottom and the right, you have it there. So that can guide you so you don't write the answer in the wrong place. The first matrix is either the top, maybe the middle, and the left, and the bottom. The second one is left, middle, and right. The combination of these two gives you which position your answer should be. What is it? Tired. What is wrong with you? Tired. How many tests did you do today?
We did a mental test.
What? Mental tests.
Yes.
Does this make sense, please? Don't worry, I'm not giving you any worksheet or whatever today.
Kill me.
Okay? That's why I didn't come with any. Okay? So let's just play with this and give you one or two to try. So now look at this question. Shh, quiet, please. If A is, now look at what I'm writing next. 1, 0, 3, 5, 2 minus maybe 4. And B is 1, 2, 3, 4, 5, 6. Let's find AB and BA. Can you try it on your own now, or I do one more?
Let's try it out.
All right, try. Just don't forget the top left stuff that we talked about, okay? I'll send these pictures to Edmodo, so you don't need to waste your time copying the example. Just use it as a guide and go straight to the question. Now raise your hand if you have done any of them, either A, B, or BA. The first thing you should do is to have the matrices written beside themselves first. Don't think about it in your head. What is the AB? If you really want to learn matrix multiplication, you must learn to write like this first. So you write A, you write B. Otherwise you get things confused. Okay? You have to learn to write them one like this, beside each other. Don't think about it in your head. Does it make sense, everybody? So try A, B, and BA. Unfortunately, we have to go.
Yeah, it's 2 by 2.
Did you get 2 by 2? One of them is 2 by 2.
The second one is 2.
Yeah, first one is 2.
First one is 2 by 2, all right. So we'll continue from here tomorrow morning. We have first period, so try this question. Maybe I upload one of these papers online, or I just send a picture. That's Ms. Roslyn is here. Anika, can you guys stop that now?